This link is for 5th grade going along with the story Up in the Air. This is part 2 and we've left off on page 724 and 725 of your Treasures textbook. So let us go ahead and begin. Daring Balloonists. Between 1783 and 1785, many men and some women went up in balloons. Some went for sport, others more daring wanted to do what no one had done before. Jean-Pierre Blanchard was one of these. Blanchard wanted to cross the English Channel from England to France. On January 7th of 1785, the wind was blowing in the right direction over the cliffs of Dover, and Blanchard and his American friend John Jeffries filled their balloon with hydrogen, climbed in, and set off for France. The first half of the trip went smoothly, but then the balloon began leaking gas. The water came closer and closer to the lighten the load. They threw everything overboard, their bags of sand, food and drink, anchors. They were still sinking, and finally they stripped and threw their clothes overboard, saving only their cork life jackets. The weather changed and the air grew warmer, heating the gas, and the balloon rose, and they sailed over the French coast, landing in a forest where they were soon rescued. Now, on January 9th of 1793, Blanchard made the first flight in North America, taking off from Philadelphia and carrying out scientific experiments at 5,000 feet. He brought back sealed bottles of air that showed that there was less oxygen at that height than at sea level. He also measured his heartbeat and found it was faster. At sea level, it beat 84 times a minute, and at 5,000 feet, it beat 92. In the years ahead, daring balloonists would keep setting records, but the chief discoveries were made in 1783, when a handful of people who dreamed of flying up and away, made the dream come true. Now, with this being said, the author says the chief discoveries in the balloon flight were made in 1783, but on the same page she writes that in 1794, Jean-Pierre Blanchard made several experiments in the hot air balloon at 5,000 feet. Tell me what questions you had when you asked yourself to make sure you understood this point the author made. What were some questions you asked yourself as we were reading this? And if you weren't asking yourself some questions, maybe you should go back and reread, because you should be asking yourself questions as we continuously read. Let's see. The author says that the daring balloonists would keep setting records, but the chief discoveries were made in 1783. So I can ask myself this question: does the author mean that the distance records were still made after 1783, but the way hot air balloons work did not change? I don't know. We're just going to have to continue to read to figure out that question. Why a balloon rises and floats. When you place a block of wood in water, it takes up space, pushing some of the water aside, and as the wood pushes against the water pushes back. This upward force is called buoyancy. Buoyancy is the force that keeps things afloat. Now, a hot air balloon rises and floats in an ocean of air for the same reason the block of wood floats in water. It has buoyancy. Now, let's go ahead and continue the way that buoyancy in water and air are similar. We just read about that. How can we compare that? When something is placed in water, it takes up space, pushing the water aside. The water pushes back, and this upward force is called buoyancy. It keeps what it is placed in the water afloat, and when the air inside a balloon is heated, some of the molecules that make up the air are forced out. This makes the air inside lighter than the air outside. The balloon is forced up when the inside air presses against the outside air of the balloon. Like all matter, air is made of tiny particles called molecules. When air is heated, its molecules spread out and move faster. When the air inside a balloon is heated, some of the molecules inside the balloon are forced out. The air inside becomes thinner or less dense. It weighs less than before it did, and it takes up the same amount of space. As a result, the air inside the balloon weighs less than an equal amount of outside air. Buoyancy carries the balloon up. Now, some gases are lighter than air because the molecules themselves are dense. One of these is hydrogen, the lightest gas known. However, it is a dangerous gas that can burn and explode. That is why balloonists today use helium, which is a slighter, heavier, but does not burn and explode. Helium is a gas used in party balloons. balloons then and now. Now, in the centuries since 1783, balloons have found many uses in both war and peace. Many balloonists have completed or competed to soar the highest or make the longest voyage. Here are a few important dates. 1860s, in the Civil War, Union troops like the French army before them used balloons to spy behind enemy lines to see how battles were going. 1875, 3 French scientists explored the atmosphere, soaring 25,000 feet in a balloon. The men took bottles of oxygen with them, but when the balloon landed, only one scientist had survived. 1900s. The early 1900s brought the dirigible or blimp. Made of several balloons, it was lifted with motors and propellers that let the pilot steer. A cabin on the underside held more than 100 people on Atlantic crossings. 1932. The man who invented a way to travel safely high in the atmosphere was a Swiss named Augustus Piccard, who built a ball-shaped aluminum gondola. Sealed inside the hydrogen tanks, he safely reached the height of 54,000 feet. 1961. Brave men kept going higher and higher. 2 U.S. Navy officers, Malcolm D. Ross and Victor Plether, Jr., went up 113,740 feet in an open gondola to test spacesuits for astronauts. 1999. Others had crossed the ocean, but Bertrand Piccard, grandson of Auguste, and Brian Jones were the first to balloon non-stop around the world, covering 30,000 miles in 20 days. Their balloon was a cross between a hot air balloon and a gas balloon. Present day. Planes have long been the way that travel the air, but you often see a dirigible carrying a TV crew above a football game or other sporting events, and they're referring to a blimp. And of course, every day, hundreds of small weather balloons explore the atmosphere and transmit their findings to Earth. All right, with that being said, let's go ahead and look at that generalization that they have under present day. It says planes have long been the way to travel by air, but you often see a dirigible carrying a TV crew above a football game or sporting events. The author makes the generalization that today you can see this happening, and it carries a TV crew above sporting events. Is this a valid generalization? Yes or no? Well, let's go ahead and take that information for the text first. You often see a dirigible carrying a TV crew above a football game or other sporting event. Let's use some prior knowledge here. I know that the word often is a clue that the generalization has limitations. Remember, we talked about generalizations that could have limitations or that were valid, okay, or universal. And of course, that word often helps us recognize that it's a limited generalization. So therefore, you often see a dirigible carrying a TV crew above a football game or other sporting events. It is a valid generalization. It may be a generalization that has limitations, but it is a valid generalization. So we could say the statement is a valid generalization. All right. With that being said, if you look at page 730, you can go ahead and read a little bit about the author, Patricia Larber. It says Up, Up, and Away with Patricia Larber. And then there are also some comprehension check questions that you can ask yourself to make sure you completely, fully understood the text. Of course, if you have further questions or concerns about generalizations, please do not hesitate to contact me.